Okay guys, here we go in 5-5. This is my second false start on the video. I'm going to have to just keep going even when I stumble and mess up. I wrote things down the wrong way. We're doing 5-5, which is double angle and product to sum to product identities. We're doing this entire section here with these 8 identities, and then we're introducing these first 4 here. So we are going to tackle 12 different identities today. The very first thing I need you to realize that I got hidden under here where I messed it up is that the cosine of 2a, that's my double angle that I'm talking about. The cosine of a double angle is not the same thing as 2 times the cosine of an angle. That's just not a true statement. If that were true, then cosine of 2 times 30 degrees would be the same thing as 2 times the cosine of 30 degrees. Well, 2 times 30 degrees is 60 degrees, right? So let's see if this works. What's the cosine of 60 degrees? Cosine of 60 degrees, if you look at your unit circle, is 1/2. What is the cosine of 30 degrees? Cosine of 30 degrees is square root 3 over 2. When I multiply square root 3 over 2, I do not get 1/2. I get square root 3. So the cosine of a double angle, I can't just say 2 times the cosine of the angle. It does not work that way. Now we are going to take a second. We're going to derive our first double angle identity so that you see how to do it. Actually, we're going to derive all 3 cosine double angle identities. We're going to show how that works, but we're not going to do the others. Let's start. Derive cosine double angle. Let's start here. Cosine double angle is the same thing as saying cosine of a plus a. That makes sense, right? A plus a is 2a. So the cosine of 2a is the same thing as the cosine of a plus a. Well, that works. I could absolutely use my cosine sum identity, but it's just a little clunky. Cosine a times cosine a minus sine a sine a, I can simplify that. When I simplify that, I have cosine square a minus sine square a. That is my first of 3 cosine double angle identities. Cosine square a minus sine square a is the first of 3 cosine double angle identities. But there's 2 more. There's only 1 sine double angle, 1 tangent double angle, but there are 3 cosine double angle identities. So let's look at the next one. Well, cosine square a, if I look at my Pythagorean identity, remember your basic Pythagorean identity is cosine square theta plus sine square theta equals 1. So cosine square a is the same thing as 1 minus sine square a. So I'm going to take that out and replace it with 1 minus sine square a. That's my substitution. And then I already had negative sine square a. When I combine those, I get 1 minus 2 sine square a. And that's my second cosine double angle identity. 1 minus 2 sine square a. But there's one more. Instead of doing that substitution, let's pull this back up here and say my first double angle identity, cosine 2a, the first one was cosine square a minus sine square a. I already substituted in for cosine square a. What if I substitute in for sine square a? Well, that would be cosine square a minus, and then instead of sine square a, I could subtract the cosine square and I get 1 minus cosine square a. Distribute, and I've got cosine square a minus 1 plus cosine square a, which is this third identity, 2 cosine square a minus 1. So we derived our 3 double angle cosine identities. We're not going to do the other 2. We're just going to write down sine double angle and tangent double angle as they are from your sheet, from your identity sheet. My only option for sine double angle is 2 sine a cosine a. My only option for tangent double angle is 2 tangent a divided by 1 minus tangent square a. Okay, now let's do this example down at the bottom. Given that sine of theta is 8/17, and cosine theta is less than 0, so cosine theta is negative. Find these double angle values. So I have information about theta. I need to figure out the missing things that I know. I'm going to use my givens as much as I can. Use what I have been given as much as possible. The first thing I'm asked to find is sine of the double angle. Sine of 2 theta. Well, sine of 2 theta, my identity right here, means I take 2 times the sine of the angle times the cosine of the angle. I know the sine of the angle. So 2 times 8/17. I don't know the cosine of the angle. So I need to do some pre-work, and I need to figure out the cosine of the angle. I'm going to use identities. I'm not going to do the sketch. I could do the sketch, but I'm not going to do the sketch. I'm going to use sine square theta plus cosine square theta equals 1. Sine is 8/17. So when I square that and move it over, I get cosine square theta equals, well, 17 square is 288. So that's going to be 1 minus 8 square is 64, 289. I'm sorry, I think I said 288, 289. So that's 1 is 289 minus. So I've got cosine theta is equal to the square root of, and cosine we said is negative. 289 minus 64, that 1 minus 64. 289 minus 64 gives me 225, and then my denominator is 289. We know the square root of 289 is 17. The square root of 225 is 15. So cosine theta is a negative 15 over 17. Negative 15 over 17. That one we had to find. When I multiply these values together, I get a negative 240 over 289. That's cosine 2 theta. Now let's look at sine, or that's sine of 2 theta. Now let's look at cosine of 2 theta. I apologize. Cosine double angle. Cosine double angle. Well, I was given sine. I have 3 options for double angle cosine identities. I'm going to use my givens when I can. This is an opportunity. This second cosine double angle identity uses sine, not that found value. Uses my given value, not my found value. So we're going to use it. We're going to say 1 minus 2 sine squared theta, where I was given that sine is 8/17, and I need to square that because that's the identity. So that is 1 minus, and 8 squared is 64, times 2 is 128, and we already said 17 squared is 289. When I turn this 1 into 289 over 289, I get 161 over 289. Don't plug this into your calculator and give me a decimal. I'm going to count it wrong. And then my last problem that I need to work is the double angle tangent. I only have one double angle tangent identity, so I'm going to use it. I know sine and cosine, so I'm going to just use that to get my tangent function value. When I find tangent, I find out that tangent of theta is going to be a negative 8 over 15 because it is sine over cosine. Double angle tangent identity says 2 times tangent of theta over 1 minus tangent square theta. We found that value, so we have 2 times negative 8/15 over 1 minus negative 8/15 squared. That gives me a negative 16/15 over 225 minus 64. I don't have that written down for me. So 225 minus 64 gives me 161 over 225. And when I do that division, I divide by multiplying by the reciprocal, I get a negative 240 over 161. Now, if I didn't need to practice that identity, I could have used sine of the double angle and cosine of the double angle right there. Okay, You guys work this next example. I'm going to put the solution up. I'm not going to show you how to work it out, but I am going to give you the answers. Sine of the double angle is negative 24/25. Cosine of the double angle, cosine of the double angle is negative 7/25. And tangent of the double angle is 24/7. Let's move to the next example. All right, we're gonna do one, and then I'm gonna let you work out the other. I like the second one better. I will give you the results for the first one here in just a second, but we're gonna work out the second one. So we're gonna do this one. Cosine of 2 theta is 4/5, and I know that theta, not 2 theta, but I know that theta is in quadrant 2. It's between 90 and 180 degrees. Cosine of 2 theta is 45, and I know that theta is in quadrant 2. In quadrant 2, x is negative, y is positive. Okay, I need to find all 6 trig function values. We're going to start somewhere. I need to start with one of my double angle cosine identities because that's what I know, and one of them that just uses one other identity. So I'm going to pick that second double angle cosine identity. I'm going to say cosine of 2 theta is equal to 1 minus 2 sine squared theta. And I was given that cosine of 2 theta is 4/5, so I plug that in. And then I'm going to solve for sine. Well, I need to subtract 1, and when I subtract the 1, it's going to look like 5/5. So 4/5 minus 5/5 is a negative 1/5 equals a negative 2 sine squared theta. And then my next step is going to be to divide out that negative 2. Negative 1/5 divided by a negative 2 gives me a positive 1/10. So 1/10 is equal to sine squared theta. And then I'm going to take the square root of both sides to solve. When I take the square root, I need to know, well, sine is we're in quadrant 2, sine is going to be positive, so I leave that like that. Square root of 1/10, I need to rationalize, and I get square root of 10 over 10 as my sine of theta. Sine of theta is my first step. Now I have an option here. I can go back and I can do it again, cosine double angle, using my third cosine double angle identity. I could use this one. Cosine double angle is equal to 2 cosine square a minus 1, and work through that identity. That would give me cosine of a. And from sine and cosine, I have, you know what, we're just going to do that. Sine and cosine, we're going to get tangent and the reciprocal functions. So my other cosine double angle, this is not what I have in my notes, but I like this way better. 2 cosine square theta minus 1. Cosine of the double angle is 4/5 still. To solve here, I'm going to add 1. So I'm going to add that 5/5. That gives me 9/5 equals 2 cosine squared theta. Divide by 2. 9/5 times 1/2 is 9/10 cosine squared theta. I am in quadrant 2, and I know cosine is negative in quadrant 2. Well, square root of 9 is 3. So I've got a negative 3 over square root 10, so that becomes a negative 3 square root 10 over 10 as the cosine of theta. From that, I can come up with my other trig functions. Tangent theta is sine over cosine. When I simplify that, I get a negative 1/3. Cosecant theta is the reciprocal of sine theta, which started out as 1 over square root 10, so that's just square root 10. Secant theta is the reciprocal of cosine theta, which started out as negative 3 over square root 10. So that becomes negative square root 10 over 3. And then cotangent theta is the reciprocal of tangent, so that's a negative 3. And there's my 6 trig function values for theta based on those given conditions. Now I said we're not going to work this other example because it would take too long. I'm just going to throw them out there for you so that you can work it. Make sure you understand the process. There you go. Okay, let's look at example 3. We're going to verify a double angle identity. Remember, when I'm verifying identities, I like to work from the more complicated side and try to simplify it to make it look like the other side. That's what we're going to do here. My more complicated side is definitely this one, cosine fourth beta minus sine fourth beta. Well, this is still difference of squares, but when I factor out to get my conjugate pairs, my conjugates are cosine squared beta and sine squared beta, plus or minus. So let's start there. Let's do cosine square beta plus sine square beta times cosine square beta minus sine square beta. Do either one of those look like an identity to you? I hope that answer is yes. This first one is my Pythagorean identity. That is just one. So I have cosine square beta minus sine square beta. That's what I got left. And I need it to be cosine 2 beta. Well, you know what? This is a double angle identity. Cosine 2 beta. We're done. That one was short and sweet. Recognize that when I have these fourth powers, I can factor. You guys do this next one. Remember, when I'm verifying identity, I'm not answering, is it? I know it is. I'm finding a way to show it. I'm going to choose to work the left. I've got a double angle identity. I need to fix that. I want to end up with 1 plus a double angle identity, and there are 3 possible double angle cosine identities to keep an eye out for. I don't like this cotangent. I don't like that cotangent at all, so I'm going to go ahead and write cotangent is cosine x over sine x. And then I only have 1 sine double angle identity available to me, so I'm going to use it. 2 sine x cosine x. And I see that I have a common factor that cancels out. That leaves me with 2 cosine square x. 2 cosine square x. That is not exactly any of my double angle identities, but one of my double angle cosine identities does have a cosine square x. If I look at that double angle identity, let's do this on kind of an aside. I know that cosine of the double angle is equal to 2 cosine of the angle squared minus 1. And what I've got over here is cosine double angle plus 1. If I add that 1 over, 1 plus cosine of double angle equals 2 cosine square of the angle, right there. This side is that, which means that I can replace it with the other side, 1 plus cosine 2x. And that's what I wanted right there. So remember to look for both sides of your identities. All right, example 4. Simplifying expressions using those double angle identities. We're going to identify which one would help us, and then we're going to simplify until we get something easier. All right, let's look at this. For example, this makes me think of the cosine double angle identity, 2 cosine square a equals 1. That's the identity that I see there, where my angle A is 5x. So A is 5x here. 2 cosine square 5x, and that should have been a plus, or a minus, not an equal. That should have been a minus. That's my identity. So minus 1 is equal to, I need to replace A here, cosine of 2 times 5x. So this piece that I was given is equal to that. cosine of 10x. Ta-da, simplified. All right, let's do B. B is sine 165, cosine 165. Well, that does not look exactly like any of my identities, but it looks almost like sine double angle. Sine double angle is 2 sine A cosine A, where A is 165 degrees, except that 2 is not there. So let's divide that 2 out of the way. Now it matches. Sine 165 cosine 165 is equal to this, where A is 165 degrees. So sine of 2 times 165 degrees divided by 2 . 2 times 165 is 330. I can't cancel that right there, by the way, guys. Remember, we said that that's not the same thing as 2 times on the outside. That 2 is in the argument. I cannot cancel it out. This is sine of 330 degrees divided by 2 or times a half. What I want is half the sine of 330 degrees. Well, look on your unit circle. Sine at 330 degrees is a negative 1/2. So this simplifies to a negative 1/4. All right. C. Which of your identities that we've been working with does this remind you of? It reminds me of cosine double angle, cosine square A minus sine square A, where A is 7x. Cosine square A minus sine square A. So that is cosine of 2 times 7x, which is the same thing as the cosine of 14x. And last one, sine 15 degrees, cosine 15 degrees. Again, this looks very similar to my double angle sine identity, but that would have a 2 in front. 2 sine A cosine A, where A is 15 degrees, but I have to divide out that 2. So that's 1/2 sine of 2 times 15 degrees, which is the same thing as half the sine of 30 degrees, and the sine at 30 degrees is a positive 1/2. So that simplifies to a positive 1/4. All right, we usually, just so you know, split this section into 2 days. We're gonna do it all in one video, because I know you can stop this video when you get exhausted and you can come back to it later. We're gonna go ahead and do this first one, and then I'm going to show you the second one, let you have a chance to work it on your own. We need to write cosine of 3x in terms of cosine x. So we need to get that triple angle out of the argument. Well, cosine 3x, I can't work with that. But if I split it apart and think of 3x as 2x plus x, because 2x plus x is 3x, this is just an angle sum identity with a double angle thrown in. So I'm going to start by addressing my angle sum identity. It's a cosine angle sum identity. So let's fill that in. Cosine sum identity says cosine of the first times cosine of the second minus sine of the first, sine of the second. Now I want everything in terms, when I'm done, of cosine x. That means for sure we need to get rid of those double angle issues. So we are going to have to clear out those double angle statements. I have 3 different cosine double angles to pick from. Remember, I'm trying to stay in terms of cosine, so that is going to lead me to choose 2 cosine square x minus 1 as my cosine double angle identity to use. I don't have a choice with sine double angle. I only have one. 2 sine x cosine x, and then that is multiplied still by sine x. So I did my substitutions right there. I got those double angle arguments out. Now the only argument is x. That's good. That's progress. Let's do some algebraic cleaning things up by distributing. I'm going to distribute this cosine x right here. So I have 2 cosine cube x minus cosine x. I'm going to multiply in this sine x, and remember this is negative here. So I have minus 2 sine square x cosine x. Okay, we're looking really good. I've got everything in terms of cosine x except for this sine square x. I need to get that sine square x out of there. Hopefully by this point you recognize sine square x, I can use my Pythagorean identity to find a replacement for sine square x. So here we go. 2 cosine cube x minus cosine x minus 2 times, and then I'm going to substitute in 1 minus cosine square x because that's my substitution from the Pythagorean identity. And I need to do some more distributing because right here I got a lot of stuff I got to get multiplied together. I need to multiply in this negative 2, and then I need to multiply in that cosine x. I'm going to go ahead and do that in a couple of steps. Let's do 2 cosine cube x minus cosine x minus 2 plus cosine square x plus a negative 2 cosine square x times cosine x. Yeah. And then I distribute this cosine. So I've got 2 cosine cube x minus cosine x minus 2 cosine x plus cosine cube x. I need to identify like terms. I've got cosine cube. So I've got 3 of those. 1, 2, 3. Oh, that 2 should have gone there as well. Dadgummit. You guys aren't here to catch that. That's a 2, just like I wanted it to be. Negative 2 times 1 is negative 2. Negative 2 times negative cosine square x is a positive 2 cosine square x, so that becomes a positive 2 cosine cube x, which makes that 4 cosine cube x's. And then I've got a negative 3 cosine x, and we have simplified. Everything is in terms of cosine x. Everybody makes mistakes, guys. I've been making my fair share today. All right, now, sine of 3x in terms of sine x. I want you to work through that same process that we used. Remember that I can write sine of 3x. I can't deal with sine of 3x, but 3x is just the same thing as 2x plus x. So I can use another angle sum identity there. I'm going to go ahead and work through it, but I'm not going to talk through it. I want you to try to do it on your own and then maybe come back and follow my steps. Remember, you're trying to get everything in terms of sine. So my odd man out right here is that cosine square. Combine like terms. And we're done. All right. Next page. page, we are going to move to product to sum to product, identities. Remember, product is the answer to multiplication, sum is the answer to addition. We are going to derive one of them. We're going to do it by adding two identities together. If you want to look to see where we are, we're right here. We've got product to sum first, these four, and then sum to product, these next four. Okay, we're going to derive the first one. Well, not the first one, actually. Maybe. We're going to derive one of them. So, yep, we're going to derive the first one. The first one, cosine A, cosine B. We're going to find it, we're going to derive it by adding identities. The two identities that we add together to get this first product to sum identity, cosine A, cosine B, and tell what it would be as a sum, is cosine sum added to cosine difference. That's what we're going to add together. All right, cosine sum, cosine A, cosine B, minus sine A, sine B. Cosine difference, cosine A, cosine B, plus sine A, sine B. Now we're adding this all together. We're adding like terms. These are not like terms. They have different arguments. So the very first thing is that I have to just say cosine of A plus B plus cosine of A minus B. That is equal to, well, these are like terms, so there are two of them. 2 cosine A cosine B. These are like terms and they add to 0 because they're opposites. I'm trying to get this product to sum identity, cosine A cosine B, so I need to get that 2 out of the way, which means I'm going to divide both sides by 2. Dividing this entire side by 2 is the same thing as multiplying by a half. 1/2 times cosine of A plus B plus cosine of A minus B. The remaining 3 identities look a lot like this with a different pattern. We're not going to derive these 3. Look at your identity sheet. Take the time to copy them down so that you've thought about the pattern. And actually think about the pattern. Look at it. See what it is. See if you can figure out things that link together. And keep in mind that you're going to be using these identities. So you need to be familiar with the pieces of them. Oops, I messed up an algebraic sign here. Sine A cosine B needs to be plus in the middle. That is minus A minus B. Okay. Once you get those recorded, let's use them. All right, example 7, using the product to sum identities. This is really much more straightforward than it feels like when you're writing down those clumsy identities. You're going to take what you're given, identify first angle, second angle, figure out what you need to do with this coefficient, and then plug in what you know. Okay, so we are using sine sine. That is this second identity right there. If you want to go, let's go ahead and write it. Let's say sine A sine B is 1/2 times cosine of the difference minus cosine of the sum. That's what I'm using right there. Okay, sine A sine B, but I've got 6 times sine A sine B, where I'm multiplying in by a coefficient of 6. A is 40 degrees, B is 15 degrees. All right, let's plug in. 1/2, but remember, I need to multiply in that factor of 6, that coefficient. So 1/2 of 6 times cosine difference, A minus B. Don't forget to use your degree symbols. Minus cosine sum, a plus b. All right, simplify. Half of 6 is 3. 3 times cosine of 40 minus 15 is 25 degrees, minus 40 plus 15 is 55 degrees. Neither one of those is a special angle, so we stop there. All right, let's talk through the next one. We've got cosine A sine B. Cosine A sine B is that fourth identity in our list, and we are multiplying in a factor of 4. 4 cosine A sine B is, well, that's going to be half of 4 out front, sine of the sum minus sine of the difference. And order matters. Make sure you put angle A first and angle B second. Half of 4 is 2. Sine of the sum is sine of 100 degrees, minus sine of the difference is sine of 50 degrees. And because neither one is a special angle, we're done. All right, our last page of notes in this section. We've got 4 more identities. Instead of product to sum, now we're looking at going the other direction, sum to product. I am not going to take the time to go through and derive any of these. I want you to copy them off of your identity sheet. I want you to look at the identity sheet, write them down, and identify what patterns you see forming. So sine A plus sine B. We're going to write it first. Instead of 1/2, we've got a coefficient of 2. We've got a more interesting argument going on in here. And please note that this last one is going to have a coefficient of a -2 instead of a +2. A similarity that you also need to pick up on is that this first argument is always a plus b over 2. The second argument is always a minus b over 2. But whether I'm using sine or cosine in the middle changes. All right, once you get those transcribed, written down, we're going to use them. We're given cosine 3 theta plus cosine 7 theta. Well, identify, I've got cosine plus cosine, where 3 theta is A and 7 theta is B. Cosine plus cosine, cosine A plus cosine B is this third identity down. So cosine of 3 theta plus cosine 7 theta is the same thing as 2 times the cosine of A plus B divided by 2 times the cosine of A minus B divided by 2. And then I'm going to simplify what I can. 2 times the cosine. Well, that's 10 theta over 2, which is just 5 theta, times the cosine of -4 theta over 2, which is -2 theta. Now, remember, never leave a negative argument. So I have to think, is cosine an even function or an odd function? Cosine is an even function. And because cosine is an even function, cosine of -2 theta is the exact same thing as cosine of 2 theta. And I'm done. All right, let's do this next one. Sine of 2 theta minus sine of 4 theta is that difference of signs, the second identity, where 2 theta is A and 4 theta is B. Order matters. So I've got 2 sine, that's 6 theta over 2 is 3 theta, sine negative 2 theta over 2 is a negative theta. Is sine even or odd? Well, sine is an odd function, so I get the opposite result, which means I have a negative 2 sine 3 theta sine theta because that negative comes out. All right, guys, good job. We survived. There are written assignments for both 5-4 and 5-5. Make sure you watch for those and see if there is an online written submission available for that. And we'll do this again for 5-6.